As we start this unit on quadratic functions and quadratic equations and applications of quadratics, we're just going to go over some basics of quadratics that you should already know, just to review and just to make sure we're all on the same page. So a couple of different things. So first, how do you algebraically find the coordinates of the vertex and the equation of the axis of symmetry for a parabola? So say you are given this equation here. How do you find the coordinates of the vertex, and how do you find the equation for the axis of symmetry? So the vertex, what you need to do is you need to find negative b over 2a. That's going to give you the x coordinate of the vertex. Once you have that, then you will plug that value into the equation in order to figure out the y value. So write this down. Vertex is negative b over 2a, and then f of negative b over 2a. So first, plug in, so negative 4 over 2 times 2. Okay, and then we're going to simplify that, and that comes out to be positive 1. And now to figure out what the y value is, you have to plug that 1 into the equation. So f of 1 is really what you're trying to find. Now plug 1 in, and we get 2 times 1 squared minus 4 times 1 plus 5, and that's going to equal positive 3. So our vertex is at 1, 3. Now the axis of symmetry is actually pretty straightforward. If you found the vertex, the axis of symmetry is just simply the line x equals whatever the x coordinate is, right? Essentially, you're finding the, for that parabola, where's the axis of symmetry? Well, the axis of symmetry goes through the vertex, and so it's simply going to be that vertical line going through the vertex. Okay, next, how do we algebraically find the x-intercepts of a parabola? By completing the square. Okay, so x-intercepts are whenever the y coordinate is equal to 0. So let's start with that. So normally there are multiple ways of going about solving this. You can try factoring. If it's factorable, you can use the quadratic formula. And then there's also completing the square. So we're going over how to complete the square. So to complete the square, you move the constant over to the right. So we have x squared minus 2x equals 5. And then what you're going to do is you're going to take whatever that b value is, which in this case is negative 2, divided by 2, and square it. And that's the number you're going to add to both sides. So it's b over 2 in parentheses squared that you're adding to both sides. So that is positive 1, so we're going to add 1 to both sides. Now, just take the left-hand side and factor that. That's going to factor into something that is a square, just by virtue of how we added b over 2 squared. So this comes out to be x minus 1 on the left, and then we can simplify the right. So we can write this as x minus 1 squared, and then now we can take the square root of both sides. So we have x minus 1 equals plus or minus the square root of 6, and then get x by itself, so add 1. So we have x equals 1 plus or minus the square root of 6, and that's it. Now, how do you algebraically find the x-intercepts of a parabola using the quadratic formula? This one's just a matter of making sure you know the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, so now let's plug that all in. So 3 plus or minus the square root of negative 3 in parentheses squared minus 4 times 2 times negative 5 all over 2 times 2. All right, inside that square root, you end up with 9 plus 40. So we have 49 under the square root. That's nice. That will come out to be 3 plus or minus 7 over 4. And that gives you two answers. So 3 plus 7 divided by 4 is 2.5. And 3 minus 7 divided by 4 is negative 1. So this comes out to be 2.5 and negative 1. All right, how to write and use a vertex form of a quadratic equation and how parts of the equation correspond to parts of the graph. So here's vertex form, y equals a times x minus h squared plus k. And in terms of how you can use that and how it corresponds to different parts of the graph, so if a is bigger than 0, so a is positive, it's going to open up. It's a parabola that opens upward. If a is less than 0, it's a parabola that opens down. All right, and then the h and the k correspond to your vertex. So the vertex is h, comma k, and then just be aware to note that it's x minus h, and then it's plus k. All right, and then the axis of symmetry is that x equals h, right? It's x equals whatever the x coordinate of the vertex. Okay, lastly, let's identify the transformations of a quadratic function and how we use them to graph the function. So this is still vertex form, just like we talked about in the last slide. But now we're going to, instead of just relating it as it opens up, it opens down, here's the vertex, let's talk about it in terms of transformations. So with a being greater than 1, you will have a vertical stretch. If a is between 0 and 1, then you'll have a vertical compression. Now if a is less than 0, so if a is negative, then we have a reflection in the x-axis. And then the h and the k here, that whatever's h, that's going to correspond to a horizontal shift, and whatever k is, that's going to correspond to a vertical shift.